Welcome to my channel AJ Studio, and today we are going to discuss a simple program that is sine of a value. Let's see the formula of a sine of a value using a Taylor series. So this is a formula for sine of a sine series using Taylor series. First x will be there. Sine of x is equal to x minus x cube by 3 factorial plus x5 by 5 factorial minus x7 by 7 factorial and so on. So you can see the patterns over here. It will be odd numbers. First it will be 1 and plus 2 and plus 2 and plus 2. So this is the way it will continue, and there will be alternative change of signs. First plus minus plus minus plus. This is the way the formula for sine x. Okay, and this is the number of iteration. This is the first iteration, this is the second iteration, third, fourth, fifth, sixth, seventh, so on. So that is the iterations you are carrying out. We'll see that in the program. So I'm going to show the program. This is a simple program of sine x using a Taylor series, and here in this, the most important thing in this program, you are going to use mat.h. Why? Because I'm going to find out sine x. Okay, here there are two ways to find out sine x: using inbuilt function sine x, using inbuilt function, and one more is without using inbuilt function. Okay, so both the things you are doing for comparison. Okay, first let us debug the program, and I will start clicking on this, and I'll click this, and here it will ask enter the value of degree and number of terms. So I will give sine 30 and the terms, number of iteration. Term means number of iteration which you have seen. I'll just show you here the terms 1 2 3 4 like that, number of terms, your iterations you want to do, more number of iterations. So I will give as 3. No, I'll give as 1 first. Okay, I'll give as 1 and I'll press enter, and you can see sine of 30 is 0.524. This is by whatever the program we have induced there. Okay, whatever the program you got the value 524, but using inbuilt function or library function, it is actually 0.5, but you can see the difference 0.524 and 0.5. So if you are giving more number of iterations instead of 1, if I give 2 or 3, you'll get 0.5. I'll show you that. So once again I'll debug. So I'll give sine 30, I'll give number of terms or number of iterations are 3. You can see the sine of 30 is 0.5, and the sine function of 30 using library function is 0.5. Both are same. So since I have given the iterations 3, so we will see what is this 3, and we are going to debug the program for sine 30 with the number of iterations or number of terms is 3. So let us debug the program by enabling the breakpoints. I'll enable all the breakpoints and we will start enabling it. Okay, debug the program. So here always the program start from int main. You can see int main. The first and foremost math.h because here mathematic function sine x is used over here, that is why math.h. Okay, int main there are some variables I, degree, n and all, and x sum is equal to 0, term. So we will see that one by one what are those. So float x, you can see over here all the values are being displayed, and values are garbage at the first, and after initialization you can see sum is the 0 over here. Okay, and enter the value of degree and number of terms. So you can see degree is there, and n is the term. So n is nothing but the number of iterations you are going to do. So scanf %d, first is degree and n. So we will see what is the degree. We are going to take degree as 30 and number of iterations are 3. Okay, n. Okay, 30 is a degree and 3, that is n value is 3. I'll press enter. So after that it's now the value of degree is 30. You can see over here degree is 30 and n value is 3. So degree 30 into 3.1416. This is pi value, pi by 180. Pi by 180, why you are doing is you are converting degree into radians. Okay, because I want my values in radians. That is why I am converting degree into radians. Is a mathematical formula. So I don't want to tell much about this, how to convert degree into radians. So degree into pi by 180. So pi is a constant, 3.1416, okay, by 180. So we'll see what is the x. I'll press and I'll continue with this. I'll continue, I'll click, and you can see the x value. X value is 0.52539998. So x value is 0.253998. This is the x value. So I got x. So this is the x value you got. So after x is stored in term also. So x is stored in term, because every time the term will get changed. So I will take x as a term in the formula. So I'll show you, just wait a minute. So I think I have closed the picture of that. Let me show that. So this is the picture of this. So here I am taking x as a term. You can see over here x, this x I am taking it as a term. So the first x. Okay. So you got 0.5235998. So that is x. So sum is equal to term. So let me click on continue. So in a term, the same value is stored, 0.5235998 in the term. So it is stored in the this one. After that, the term is stored in sum also. In a sum, the same value is stored. Okay, every time some value will be changed. Every time it will be changed. So now the for loop. In for loop, the iterations, you can see the iterations. Anyhow, you have stored x. The x is this one, the first value. The x is the first value. So afterwards, you know that this is I is 1 here. I is 1. That is why x to 1 by 3 factorial. So here next value will be 3. Why? Because in formula x cube by 3 factorial is there. So we will take I is equal to 3. I is equal to 3. I less than or equal to n. N means number of iterations that I have taken here. Okay, number of iteration. And you can see in for loop I plus 2. Why? Because every time when you do one iteration, here x is 1, okay, here x is 3, here x is 5, x is 7. So the change, okay, change between two variables, these two, okay, those two transition is 2. That is why you are giving plus 2. So x plus 2, x 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. That is why you are giving incrementation of 2, which will start from 3, from here 3, next iteration it will be 5, next iteration it will be 7, next iteration it will be 9. So that is the way it will work. Okay, we will see. I will minimize this. So I will click on this. So now for I is equal to 3, you can say I is equal to 3, I less than, so I is 3 less than or equal to 3. So it will go inside. Okay, term is equal to minus term into x into x. So minus term is what? You know what is minus term? That is term value is 0.255, then into x is 0.25, that one it will multiply with this, and I is 3, I minus 1, so 3 minus 1 and into 3. So now I will click on this. We will see what is the change of term. Okay, what is the change of term? You can see now you got some value minus 0.02392462. So this is the term value. You got term as minus 0.0239246762. This is the term value. So now in the next line, you know the sum value, this one. So you are going to add sum and term. So anyhow it will be, now the sum value will be changing. You can see the sum value will be changing. You can see sum value will be around 0.49967,521. So this is the way it will work. So this is the way. So it will show as 0.4996751. This is the value of sum. Okay, this is the value of sum. So it came out after for loop is false, it came out. Okay, so I'll continue. Now it will print. Okay, now it will print sign of percentage D is percentage 3f. Okay, 3f, you know, point 3f means after point only you should display 3 digits. Okay, after point you should display how many digits? 3 digits. So that is for the C. You can see over here the sum value is 0.4996751. This is the actual value of sum. We'll see what will happen. You can see over here when I mouse over here 0.4996752. That's the value of sum. But here you are going to display only 3 points after that. Okay, so now I'll press on continue. So now I will show the output once. You can see here the sign of 30 is 0.500. Okay, it is so 0.499 means it will take 0.5. Okay, it will take what? 0.5. Since I am doing 0.3f, since I am doing only 0.3f, after point only 3 digits it's displaying. After point 1 2 3 digits it's displaying. That is why it is showing 0.5, which is 499 is almost equal to 0.5. Okay, next the sign. Now this is the sum you got. Now next printf, it will display the sign function of 30 using library function. Here it will display using what? It will display using the sinex. Sinex is an inbuilt function to find out the sign value. So where is this sign value? Sinex. This is defined under mat.h. This header file mat.h. This is an inbuilt function, but this sum is which you are finding out over here. So that's the difference. Sum is just to find out using your user defined program. Okay, user will define the program and return the logic. According to that, the sum is displayed. But sinex is an inbuilt function to find out the sign of the value, and this is the output. So sign of 30 is 0.5. How you got 0.5 you understood. And one more thing I would like to tell once again, this is the formula for sinex using Taylor series: x minus x cube by 3, x5 by 5, x7 by 7. Here the logic is very simple. It's over here. I'll just highlight this. This is the formula. Okay, you are taking x as term, x as a term. You can see here x as a term, this one x. Then remaining it will be from it will start from 3. That is why I is equal to 3, I less than n plus 2, because there is incrementation of two values between these two values incrementation. That is the major thing. And always the term will start from minus, because here every time it will be minus. That is why you are giving it as minus over here. And next time we minus into minus will be plus. Then next time plus and minus, again minus, then minus plus. So that is the way it will continue. That's the way it will continue. And this is the simple program to find out the sign of the value using Taylor series. And thank you so much. Thank you so much for watching this video. And I'm signing off. And this is AJ Studio once again. And thank you so much. And please don't forget to subscribe, share, and always like. Thank you.